Ali, make sure you unmute yourself and start your sharing here when you're ready.
Yes, sure, Jeff. Okay, so thank you, Jeff. Thank you, Prasanna, for handing it to me. And thank you all the audience who are here for attending this event. I am Ali Tariq. I am working as an associate hardware engineer focusing on CI perspective of RISC-V. And Cloud5 is actually an R&D project at 10x Engineers focusing on CI part of the RISC-V, and it is actually in collaboration with the RISC-V Labs initiative. So let's get going and see what problems are there which Cloud5 solves and what Cloud5 actually is. So a little introduction about 10x Engineers. We are design and verification services company that's focused exclusively on RISC-V and image processors, two domains that are growing rapidly. Our team of 70+ engineers has deep expertise in RTL verification and compilers and tool chains. With clients around the world, we are building some of the most cutting-edge chips for data centers, automotives, and 5G technology. We will be in RISC-V Summit, Barcelona next month. If anyone wants to meet us, we will be happy to meet. We have been proud contributors to the RISC-V ecosystem. And the work I am presenting today is an effort to remove a key bottleneck we see to the rapid adoption of RISC-V in the RISC-V software and hardware ecosystem. I will be discussing that right now. So this is where we are, and this is what is actually the problem statement. So hardware vendors develop RTL for RISC-V, and they want their built hardware to run successfully that software which software developers want to run. On the other hand, we have software developers who want to run and test their applications and programs on RISC-V architecture, but there is no easy way to do that. There is actually a chicken and egg problem there. The software developers have to set up an environment, or they have to buy RISC-V hardware boards to set up and get going with the RISC-V software development and testing or execution of their programs. So, and there is another problem in hand, which is actually the hardware boards of RISC-V, which we can get from the hardware vendors, are actually not up to date with the latest RISC-V specification, which is because of the SoC fabrication and verification process. And on the other hand, the hardware vendors are actually focused on hardware development and design. They don't want to set up their own developer tools and SoC. And on the other hand, software developers are actually focusing on RISC-V software development and contribution. They really don't want to get them in all the hassle of setting up environment and buying their own hardware boards. So all this can be solved using Cloud5. Let's see how we can do that. So what is Cloud5? It is actually a CI/CD platform for testing RISC-V applications on real and emulated hardware in the cloud. We have all the necessary tooling available for building packages for RISC-V out of the box. Neither do you have to buy any RISC-V board, nor do you have to set up any kind of environment on software level for that. You just have to get yourself on the Cloud5 and you are good to go with just a few clicks right away. You will be able to interact with hardware boards as you like, or you can also play with the emulated instances. So this is what Cloud5 has to offer. We have real hardware as well as emulated hardware instances. In the real hardware, you can see that we have Hifive Unleashed and Starfive Visionfive 2. We have also other boards coming, and as they come, we will add to the platform. There are multiple Hifive Unleashed boards and multiple Starfive Visionfive boards. We also have emulated hardware computes, which includes QEMU user mode, which can run single applications and also run the binaries which are compiled for RISC-V, which can or cannot be simple source codes. And we also have full QEMU Linux simulation, which means users will have full access to a running Linux distros, and they will be able to do development on the Linux distros. Real hardware ensures that you have complete reliability of running your application on a real hardware board, whereas emulation compute instances ensures that you are running with up-to-date RISC-V specifications, thanks to the up-to-date upstreams to the QEMU repository. So here is a list of languages and build tools which Cloud5 supports. Cloud5, as you can see, support Python, Ruby, Java, and many other languages. We are constantly updating this list. And there are also build tools. Here you can see Flex, Python, Ninja, Make, CMake, and other tools which developers can use in process of building their tools. There is another important section which you can see compilers and tool chains. You see, developers do not have time to set up all these things, including tool chains and compilers and other frameworks and other stuff like SSL, gperf, and other libraries. They just want themselves to get readily on the environment on which they can do the testing and execution process readily integrated with their environment and softwares. This is not the complete list. You can actually see the complete list over here. We will post the link after the end of the presentation. So let's get ahead. So this is the workflow for a user who is going to use Cloud5. First of all, a user can request an account for Cloud5 at cloud5.co. Once a user gets an account, user can add the personal authentication token of the repository on Cloud5, which makes sure that user can use Cloud5 and integrate the repository with Cloud5. So everything is completely automated. After that, users, depending upon whether or not they want to use automated builds, they can add webhooks into the GitHub or GitLab repositories. In the repositories, when they configure that, they can also choose whether or not they want to trigger the builds with pull request or push or other events. After they are done with this step, they can go straight ahead and add a pipeline script into the repositories. Users do not have to worry about this step because we readily provided documentation which we created, and I will be posting the link after the presentation. It is right at the end of this presentation. Users can create their own pipeline scripts using that documentation. They don't have to rub their heads right away for and go into any hassle for creating that, and we can also assist users for doing that. So after this one-time setup is complete, users can run their pipelines and see the status on the dashboard of Cloud5 as they continue to develop their applications. We have also a demo at the end of this presentation, which I will be giving to you regarding the CI/CD stuff, because keeping in view, this is the most important part, which is running the pipeline and doing all the development stuff, because you can see that up there, this is just a one-time setup. So here is the Cloud5 dashboard. You can see this is pretty much self-explanatory. On the left side, you can see that there are compute instances which are RISC-V hardware and RISC-V emulation compute instances, and their status is also shown, which is showing that they are idle, which means they can be put to use. In the center, you can see that there are build status, which indicates that whether or not a build has succeeded or failed. And then you can see that there are weather reports based on the previous results. Here you can see that it is showing sunny, which means the trend of whether or not the build has successfully passed is actually showing that your builds have all passed. And here you can see that it is showing rainy, which means that builds which you have run so far are not succeeded. Here you can also see the pipeline view of a build. On the right side, you can see that there is a time of each stage and whether or not a stage has passed. Here you can see that as a stage has failed, user can check on it whether or not there is a problem with the stage, and they can also check what is the problem with the stage. And once they go into the specific number of build, they can also check other details like console output and other stuff. So this is how the console output looks like. In the console output, you will be able to see the detail of all the build, and you can see what has gone wrong if your build has failed. Here is the you can see the build has passed. So this will show all the steps and all the commands and their output accordingly. So users will be able to see the outputs of the builds for which they are concerned. So let's get to the interesting part. This is the demonstration. In this demonstration, I will be showing how an integrated GitHub repository can trigger a build once a pull request is generated. So let me go to the Cloud5. It is hosted on the cloud5.co right now. Okay, so this is the landing page of Cloud5, where you can see that there is a get access button. From here, you can request a Cloud5 account, and you can fill a form and tell us what your use case is, and we will get back right to you. So I'm going to proceed with Cloud5 dashboard. Okay, so this is the Cloud5 dashboard, and here I have some demo builds already prepared. So here are some demo pipelines which I have already prepared. I'm going to proceed with Cloud5 Hello World Visionfive 2 pipeline. Okay, so I am going to proceed with this repository, which I have already linked with this pipeline. So this takes me to the GitHub page of the repository. And over here, I have a branch called test branch. I'm going to commit a change in here, and I will be showing you what happens when a commit is pushed into the branch and once a pull request has a commit going on. So let's see what is the source file. So this over here is the source file. In the source file, you can see that there is a C program. In the C program, you can see that it says hello world in PR. So it will print a message in the console if our build is successful. So let's make a change. I'm going to remove this redundant line just for the sake of pull request. Here you can see that we have a pull request, and after there are no conflicts with the base branch, we can see that some checks have not completed yet. And if we click on the details, which I'm going to open in a new tab. Okay, so this takes us to the Cloud5 page of the pipeline, which we integrated with our repository. If we go to the console output, we will be able to see that our console output says that our build has been successful so far. So if we scroll down, we can see that it prints the message hello world in PR. If we go back to our repository and see what a Cloud5 pipeline file actually is. Okay, so this was the file which we used, Cloud5 pipeline Visionfive 2. So over here, you can see that first of all, we have a node directive over here, which indicates which compute instance are we going to use. So there is Starfive Visionfive 2 board. So where this comes from, I'm going to show you. This comes from right from the build executors, which are actually the compute instances, which I already showed in the presentation. So here are some compute instances like Hifive Unleashed. There is a QEMU over here, then RISC-V runner one, which is actually the QEMU Linux. And over here we have Starfive Visionfive 2 board. And we can type this string in the node. So once we have specified a node for our build, we can get ahead. After that, we have a line called checkout SCM. So what this does is that it clones the repository on the compute instance, which is effectively Starfive Visionfive 2. After that, we have first stage of our pipeline, which is actually the compilation phase. So this is merely the name of the stage. What happens in this stage is that this is just a comment compiling hello world.c using bash commands. After that, we have an sh directive, which specifies that we are going to run Linux builds, commands over here. And over here, we have a block with quotation marks, single quotation marks. And inside that, we first of all have shebang and then bin/bash, which indicates that we are running a bash script. And after that, I am sure all of you will be familiar with this. We have GCC, and we are doing nothing but compiling the hello world.c file, and we are also mentioning its output file name is hello world.out. So once this is completed, our stage ends over here. And once our stage completes, the next stage starts. In the next stage, what we are going to do is that we first of all mention the name of the next stage, just like we did over here, which is compilation phase. Here we have running binaries. This is merely the name of the next stage. After that, we again have an sh directive over here. And after this sh directive, we again have a triple quotation marks block. And in this block, we have shebang bin/bash, which indicates that we are running bash script over here. And in the bash script, I am sure most of the people in the audience will be familiar with this. We are actually executing the hello world.out file, which is nothing other than the same file which was created in the first stage, which is compilation phase. And once that is done, the stage is complete. And after that, you can see over here that our node ends here, which is the last bracket over here. And we are done with our build. So this is what actually happens over here. And you can see there is nothing difficult with this pipeline file. User can create it. And much of this file will include the bash script. So this was all about the demo. Let me go towards demonstration. And okay, so I will be taking any questions now. And here are some links, some very useful links which you can use. First of all, we have user guide, and we have Cloud5 channel where there are and will be some important videos about Cloud5, which includes onboarding video and stuff like that. If you have further queries after this presentation and in the future, you are very much welcome to contact us at cloud5@10xengineers.ai email. So Jeff, can you tell me if there is any question?
There are no questions at this time. I will remind people that if you want to ask a question in person, you may raise your hand and I will mute you and allow you to ask that, or I will unmute you and allow you to ask that question. Or if you would like to type it in, you could type your question into the Q&A or into the web chat. While we're waiting, I'd like to, Ali, sort of take you back to a couple of the questions we had previously. Remember, we had the question asked of Prasanna about level of access and how many things could change. You certainly have given us a demo that shows how to use Cloud 5 as a Jenkins server on the back end and integrate that into GitHub, which is incredibly powerful. I guess the question for you is, do you envision any other different types of access, sort of board level or VMs or containers, like, you know, what we have traditionally called sandboxes, sort of thing? Or do you have or do you plan to keep this really at the GitHub, or sorry, I'll say the Jenkins runners sort of level? Does that make sense?
Yes. We are actually working on giving users the direct access to the boards. If there is much demand of it, users can always contact us at the given email regarding whether or not they want to access the boards, and we will be very happy to communicate with them and see if their use case meets our requirement.
Okay, excellent, great, great question, or sorry, great answer. Let's see if there are other. I think the other question that was asked that I answered sort of in between times that I think is worth addressing was, there were a question about, you know, could I run an application, you know, around the world and tie in the back end, say, you know, at the Cloud 5 lab, right? So maybe run it out of the US and tie in your app, your back end. And the answer to that is one of those sort of it depends sorts of answers, right? I mean, it depends upon how latency sensitive the applications are and what you're trying to tie in. In the case of the Jenkins runner, it's a lot more maybe tolerant of some of those. Although, you know, if it's a long enough test, it might be sad, or it might be a little slow, or, you know, so. It's still probably it depends, but it does lead to the question, which is where is Cloud 5 sort of hosting their servers? Where are those today? You know, the emulation versus the boards, and you know, would you take on sort of latency as a topic? Whether you've seen or done any latency measurements that would help people decide whether they should be using Cloud 5 or not.
Okay, so as far as the emulation instances are concerned, I don't think there will be much issue with the latency, as they are hosted on the live servers. Whereas as far as the boards are concerned, RISC-V hardware boards, they are hosted in the 10x engineers workspace. So, but I don't think we have not yet faced any kind of latency issue. So I don't think there will be any.
Great. So I think it would be an excellent exercise for people to try and work on that. So, all right, let's see. Question I have from Deval: how do we envision the lab being useful to end users? Is it mostly from an educational perspective? I would throw in perhaps, or a development perspective. You know, I think it's a great question. How would we envision that being used?
I think the question is more like if it is limited to the academic perspective.
Yeah, no, that's a great way to summarize it too. Yep.
Okay. So it is not limited to the academia perspective. Actually, anyone can use them, and any organization is actually welcome to use our platform. And even if you are in the academia, you can always contact us and use our platform.
Okay, great. And Guru points out that your 10x engineers link to the user guide doesn't appear to work. So maybe you want to try clicking on that on this screen and see if we need to make an edit or figure out what might not be working.
Actually, should I post it in the chat?
It looks like you're missing a hyphen between X and engineers. But yeah, if you want to post it in the chat, that would be great.
Okay, let me. So I have posted in the chat.
Great. Actually, it looks like it just went to the hosts and panelists. I'll repost to everybody there, Ali, and I'll put it in for Guru's answer as well. So we have it in a couple places. All right.
Yeah, the user guide is working fine.
Yep. Muhammad asks, from hello world to full-blown application emulations, question mark. How would the growth look and how would you envision this shift? My sense is maybe they're questioning the, the efficacy of emulation in this. I'm not quite sure exactly what Muhammad's asking here, but I think it is a fair question, at least in the context of application scaling. How does emulation work of the RISC-V platform? What has been your experiences there? I
think you get it right. It is actually about the complexity of the program or application. In talking about the complexity of the application, the Hello World is just a demo. We have already built Python and we have already built Rust, and you can see the languages we have already built. That means they are all supported in the Cloud 5. And if you have another complex application which you want to build, you are very welcome to come and start your development on Cloud 5 platform. And if there are any hurdles, we will be very happy to collaborate with you.
Yeah, it turns out there was really an interesting discussion last year at Summit in December when Bilal was there and we were on Members Day, and I was talking about labs, and we had commented on the fact that Cloud 5 was going to use emulation, and there was a gentleman, and I don't remember the use case. It was something like one of the compilers or something, and he said, listen, I already have trouble compiling this on a single node all by itself. How could this practically work for emulation? And Bilal and I looked at each other and said, you're right. There are going to be limitations. Some of these big compiles, some of these big things that need big memory footprints, need big storage footprints, and use every compute cycle to go do it, are not great examples of emulation or an emulatable or a simulator sort of workload. However, there are lots of smaller sorts of applications. So kind of like latency, the answer is it depends. But I think you folks have proven that there are some great use cases where simulation or emulation of the platform will work quite well, as have several of the other environments that are available to simulate these platforms. So I think I appreciate the work that you've done, and it is a great question, Mohammed. I like it very much, and thank you for raising it. Let's see if we have anything else. I don't see anything else in chat. I do see that Bilal has asked a question. He says, the question for the audience, are there any developers of open source applications who are keen to port their applications to RISC-V? And I'm assuming when he says take it out for a spin, maybe he means Cloud 5. If so, what has been your experience? What are your challenges? And ultimately, he's asked how can Cloud 5 help you with that, or IITM labs as well. So I think that's a great question to sort of see if anybody wants to raise their hand and ask that question, or wants to talk about that. I think that would be a great way to kind of wrap this up and see if anybody has any feedback or thoughts. While we're waiting for that, I do think that somebody asked a question: how do we find this meeting's recording? The recordings will be posted right back out at the Technical Sessions website. And so that will be there. It will get published when it gets reported. And I think Raphael can correct me if I'm wrong. I think he also posts it to Live Tech Announce or something that the things have been either Tech Announce or All-Mem. One of the main mailing lists will have a pointer and a reference to that when it becomes available. So, right, Raphael?
Yeah, I need to go to all members. So everyone's going to receive that in 24 hours.
All right, let's see. And anybody want to raise their hand and ask a question? I don't see anyone raising their hand. So I do think we are at the point, unless let's give you Ali one final set of thoughts or comments here. Then maybe we'll go to Prasanna and let him see if he has any final comments. But anything you want to sort of wrap up with, Ali, before we call it a day here?
Okay, so I would like to ask the audience if they have any need of the libraries which we should add to our platform, or is there any use case they want to implement on our platform? We will be happy to add it if there is any.
And these would be great questions to send to you, perhaps at your contact information, or great answers or things to engage with you. I think your previous slide had that, right?
Yes.
Okay. There we go. Contact us. That's right. Okay. So cloud5@10xengineers.ai would be a great place to send questions and engage with the team on that. Excellent. Thank you very much. Prasanna, any final thoughts, questions, comments, anything you wanna raise here before we wrap up?
No, just nothing in specific. I think maybe we can publish where there's some people asking where they can find the recording. Also, if they have any questions, they can reach out to our lab partners group or the mailing list, where we can pick up the if there are real-time problems according to the need.
Yeah, I think that's a good reminder and something I can work with Raphael to make sure we get in the announcement when it goes out. I do want to say thank you to both of you. Starting to promote RISC-V Labs and promoting RISC-V Labs is a great thing. This is, folks, an emerging initiative for us in RISC-V. It's important to help us grow the ecosystem, as you've heard from both groups of people. And it's going to be a key part of what we need to have to help be successful in the future. So I appreciate Prasanna and Ali bringing the status of their work out and sharing that. Thank you very much, folks. And that will end today's session. Thank you, everybody who attended, and thanks for the great questions. Bye-bye.
Thanks, Jeff. Thank you, Raphael, for giving us a forum.
Thank you all.
Okay, bye.
Cheers. Bye-bye.
Bye.